In this video, we are going to convert this Pine script indicator into Python. So this actually is done really well. This is a strategy that I went ahead and built, and it uses 3 different indicators. And if we go over here to, let's see, strategy tester, performance, looks like a -5%. I think I'm on the wrong chart though. Yeah, I'm on the wrong time frame, but it should be okay, 58%. So you can see it's up 58% while the rest of the Bitcoin is down 56%. Now this indicator here is in Pine script, which is TradingView's code language, and we're working on it. We're going through, and we've been working on it for the past couple of videos. So just stick around, watch this video, and I'll show you exactly how to do all this. So we're at the point where I pulled in all of this information, and I'm not going to explain it all. You can see it in the other videos if you want to, but I think if you just watch this, you'll be able to understand how to convert everything into Pine script. We stopped right here, so let me go ahead and run this to make sure it all works. So it looks like we have a little bit of an error, but that's because I haven't finished yet. So we'll go ahead and we'll keep it moving. So essentially we got to about here, time.sleep, and let's put a sleep in there, and let's go ahead and print out the data frame that we've built. And I'll keep this code over here on the right so we can see it. And this is the data frame we have thus far. So you can see we got the DAR, which is TA. You're using a little TA, and I'll just show you how to do that really quickly. We just use the TA library, and we pull in the indicator, EMA indicator, and then we put in the data frame that we built above, and then we also send in the Wilders period. Now the Wilders period, if you look at this is actually pretty Pythonic, so it's already like in Python language pretty much. Now we're going to move on to another part. Since we're just moving straight through this, let's go ahead and see where we are. We're right here now, and this is a good place to start because you're going to be able to see one of the trickier things. You can see long band here, and if I go to my code, let's go ahead and check it out. You can see this right here that's highlighted is this which is highlighted. So this is the biggest thing that's different between Pine script and Python, in my opinion, or one of the biggest things. And I'll explain it all right now. So in Python, we usually just say long band equals whatever, right? And it equals that. But in Pine script, you do 1 equals. If there's an equals, then anytime you want to override that, you have to use this semicolon and then equals in order to override it. But this is a pretty tricky function, right? Because it's showing this and this. What does this even mean? Well, essentially, if you look at this, it says if. So we can kind of disregard what's highlighted right now, but it takes this. If the RSI is bigger than the long band, so if RSI 1 is bigger than long band 1 and RSI index is bigger than long band 1, RSI index bigger than long band 1, then it sets, it resets the long band to this right here. Now, if this were false, this right here, if this were false, it would set it to that. So you can see I pretty much do an if statement, long band equals that, else long band equals that. So we go over this multiple times throughout, so I know this might have been a lot if this is the first time you've ever seen how the conditional statements are changed from Python or Pine script to Python. But we'll keep working through this, and you'll be able to see exactly how it works. So down here we have the short, we have the trend. DAR, we have to make sure here that DAR is up here. So DAR equals that, source.dar, and then DAR actually equals source.ilock, because we have to go into the data frame now, and we want to say ilock -1. We want the last position of that DAR. So I just type in DAR, because remember right here we added this to the data frame, so we always have the DAR. But this is saying, hey, set the delta fast ATR to DAR. And we might want to go ahead and say source DAR.